So guys, welcome to Coding Pivot. In the edition of this video, our duty as a data scientist is to build a machine learning model, a dependable system that can actually determine if a patient have diabetes or not based on some certain features we are going to be giving it. Okay, so we have the data set that contain features such as the BMI, blood glucose level, hemoglobin level, okay, and other features, okay, which I won't be able to mention here. I mean, there are a lot of features in the data set. Okay, so we have to take this feature as a data scientist, process it and fit it into our model to see how accurate our machine learning model is in predicting if a patient have diabetes or not. Okay, so in this video we are going to be doing a lot of data visualization. Okay, I mean, that's the role of a data analyst, to actually make data in such a way that is understandable by both data scientists and non-data scientists, or technical people and non-technical people. Okay, so let's head on to this video as we actually see how the power of machine learning model can actually assist physicians or doctors in the medical world. Okay, let's head on to this video.
So here we are in our notebook about to start the project. So the problem statement that we're going to be solving in this our data science project is to use to develop a machine learning model that can actually predict the likelihood of an individual developing diabetes based on a set of predictive variables. Okay, predictive variables like your age, hypertension, heart disease, gender, smoking history, BMI, and many other predictive variables we are going to be checking out later. This model will aim to assist healthcare providers in early diagnosis and intervention, ultimately improving patient outcome and reducing healthcare costs. Okay, so that's basically what we are going to be doing in this video. We are basically going to build a machine learning model that can predict if an individual have diabetes or not based on some predictive variables or some independent variable we are going to be giving our model. Okay, the first step in this project, we are going to be importing our required libraries. Okay, importing our required libraries. Importing required libraries. Okay, so the libraries we are going to be using for this project are going to be importing Seaborn for our plotting, SNS. We're also going to import matplotlib, as PLT. Then we're going to import pandas as PD, and also we're going to be importing our numerical package, which is numpy np. Okay, so let me import these variables now, these libraries now. Then the next step is our data set. Okay, we're going to be reading our data set. pd.read is a CSV file. So I'm basically just going to use my pd.read CSV to read the data set. The name of the data set is medical diabetes data set CSV. Okay, let me check the head of my data. Okay, here you can see what I was talking about. The columns in our data set, which are the variables, we have gender, which can be male or female, age, hypertension, heart disease, smoking history, BMI, which is your body mass index, your HbA1c. This basically means the amount of hemoglobin in your red blood cell, your blood glucose level, diabetes. This is our dependent variable, which we are going to be predicting on. If it's diabetes, is 1. If it's non-diabetes, is 0. Okay, then pregnancies. Okay, this, as I said before, is only limited to ladies. How many times have they been pregnant before? In this scenario, the lady have just been pregnant for just 2 times, 8 times, 5 and 2. Okay, so let us use the df.info to get a general overview of how our data set look like. So here you can see here my gender column, and you can observe that from all these our column here, there seems to be none of them that have a missing value. Okay, and we just have just one that is object, okay, which is categorical. No, we have one and two here. Okay, just two of them are categorical. We're going to be handling this later on in this video. Okay, so the next step now, let's actually perform a univariate analysis on this our data set. Okay, univariate analysis. Okay, univariate analysis, which is simply analysis of each of our column. Okay, which is analysis of each of our column. In this type of analysis, we don't actually consider the relationship between all of the column. We just take one column, get an overview of it, if there is presence of outliers, the maximum value, the minimum value, and order and distribution of data. Okay, to do this, we are going to be using and plotting an histogram. Okay, we are going to be plotting an histogram. I'm going to say my df.hist number of beans should be equal to 15. Color should be red. The edge color should be black. The label size should be 8. White label size 2 should also be 8. Then the line width should be 1, and we are going to be setting grid to, let me just take this down. We are going to be setting grid to false. We don't want grid on our plot. Then we are going to give a tight layout. Okay. Then let's give a subtool title. Okay. Okay, so let us show our univariate analysis plot with our histogram. What's the error? Oh, we forgot to place a rectangle here, a rect here. Okay, it should be. Let me run this again. So here we have it. Here we have our plot. Okay, let me zoom out a little bit. Here we have our plot. You can see all our plots here. There seems to be no outlier in our plot. So I said before, this is the advantage of univariate analysis. You can easily analyze if there is outliers in your data set or not, and also the distribution of your data set. Okay, from what I'm seeing, our data set here is okay, so I don't think there is any much analysis more to do here. So let me head on to the multivariate analysis. Okay, multivariate analysis. Let me paste the multivariate analysis. Okay, variate analysis. So in this multivariate analysis, is simply analysis where we consider the relationship between each of the variable. Okay, how each variable affect each other. Okay, and one of the best plots to actually though multivariate analysis is actually the heat map. Okay, the heat map is one of the best plots to actually do this multivariate analysis, because it actually shows you how each variable affect one another. Okay, so to do our heat map is we're going to get a correlation table. Okay, correlation of our plot. Let me just see here. You can see how our each of our plots affects each other. Okay, you can see all of them here, though this is not quite readable because of, you know what, let's make this more visually appealing. Let's plot a heat map with this variable we got here in this table. To do that, I'm going to say plt.figure. I'll get a fixed size. Okay, fixed size should be 12 by 8. This is the dimension I want my plot to be. I would be using Seaborn for this. Seaborn have actually provided a way to actually plot this heat map with extreme ease. I want to just place my table here. Then I'm going to set a note to true, annotation to true, and my FMT, which is basically the decimal places I want my values to be approximated to. I want 2 decimal places. Then my color map should be cool warm. Okay, cool warm. Set my line width to be 0.2. And just give a title. Font size of 14. Okay, and show this. Okay, and show this. Here we have our plot. Let me just zoom out a little bit so you can see the correlation, how each of our variables affect each other. Here you can see the most correlated variable with my diabetes is actually the blood glucose level. Okay, this actually explains it. I mean, glucose level in the blood is actually one of the major factors that determines if someone have diabetes or not. Okay, if you have a high glucose level, it will automatically translate that to an extent that you have diabetes. Okay, and also this our number of hemoglobin in the red blood cell, and also your BMI, your heart disease, hypertension, and okay, your age also plays a high role in determining if you have diabetes or not. Okay, all these factors actually determine if you have diabetes. Okay, some of them that have extremely low correlation is this pregnancy one here. Okay, so let's actually compare each of these, some of these variable here with this our diabetes column. Okay, because I mean this our heat map over here, it's just showing us values of how they affect this diabetes. It isn't actually giving us detail of how they affect it. Okay, it's just giving us value. So let's actually deep in detail of how this variable affect this our diabetes. Okay, so first column which we are going to be comparing the blood glucose level and the diabetes. Okay, let us see how the blood glucose level actually affects the diabetes. Okay, so to do that, let me just okay, so we're going to be comparing the blood glucose level and the diabetes. Okay, so to do this, I'm going to be using a bus plot. Okay, because bus plot is going to give us the exact detail of what we need here. Okay, I'm going to simply say sns.busplot. I'm going to say my y is equal to blood level. Then my x is my diabetes. My data, and what I'm going to be using is a color line. Okay. So here we have the plot here. You can see that patients who have a blood glucose level above 150 tend to have higher risk of getting diabetes. Okay, that's what this simply means. You can see here patients whose blood glucose level is greater than 150 tend to have diabetes from our observation here. Okay, so let's also compare the which other one have high correlation with it, the hemoglobin level. Just going to say showing the hemoglobin, hemoglobin level. Okay, and diabetes. So as usual, I'm also going to use a bus plot for this. Bus plot. My y is going to be the hemoglobin level. So the way the spelling is in this my column is actually really funny. I'm going to be very careful so I don't mistake. Okay, this is one mistake the spelling. C and level. Okay. I still wonder why they didn't just spell the hemoglobin instead of using these encoded words. Okay. So with diabetes as usual. Diabetes, and my data is my df and my lattice color line. Okay, let me run this now. What's going on? Okay, let's say hey, pala. Okay, this is supposed to be an E here. See, run this again. So here you can also see that okay. So you can see here patients who have hemoglobin level above 6.2% tend to be diabetic, have higher risk of getting diabetes. Okay, so that's what this correlation simply mean. So I think this is enough of the multivariate analysis we have done. I think this is enough. But you can also compare, use this box plot to compare other column with the your target variable, which is our diabetes. You can also compare the age with the diabetes and see how the age influences the risk of someone being diabetic. Okay, so let's head on to the next part of this edition of this video, which is handling of categorical data. Okay, handling categorical data. Okay. Okay, so as we have seen before, we just had two columns that are categorical. Okay, let me just do this again. We just had two, which is the gender and the smoking history. Okay, so to handle this categorical data, we're going to be converting it into numbers. Okay, we're going to be converting it into numbers because I mean that's the language which your machine learning understands. You're not just going to pass it a test. I'm going to pass it numbers. Okay, that's what we're going to be doing now. So to do that, I'm going to be using my pandas.get dummies. I'm going to say df should be equal to pd.get dummies. And by the way, this is a one hot encoding method. It's going to one hot encode our categorical columns. Okay, I'm going to say df my data frame and column I'm going to be encoding is going to be smoking history and gender column. Okay, let me check my df now. What's going on? Yeah, I'm getting unexpected argument column. It's supposed to be an s here. Okay, let me run this again. So here we have encoded our categorical columns. See here, smoking info, smoking history, no, the info, current, no, ever, former, never, not current, and also this our gender column, which is basically male and female. Okay, we have one more gender here, which is order. Okay, well, I mean, we're going to be deleting this order because I mean, if you are a male or a female, it automatically tells us that you are order. So we're going to be deleting this column here. We won't be needing this. Let me just come down here and type my del okay, df gender order. Okay, let me delete this. Yeah, I think it's over now. Okay, yeah, I've deleted it now. It's no longer here. So now we just have a data set that have 16 column and 100,000 rows. Okay, this is a kind of a very large data set. Okay, so I think we are done with our exploratory data analysis in this video. We are done with it. I mean, we have done univariate analysis, multivariate analysis, and we have handled categorical data. I think that's all the issues we had with this data set. We didn't have any missing column or any of such. Okay, I think that will be all for this video. Okay, I will place a link below that will take you to the next video where we dive into the world of machine learning and use the machine learning algorithm, as I said before, your logistic regression, that will be fitting all this our preprocessed data set into the algorithm to train it and make prediction on our test data. Okay, I still remain your host, and don't forget to subscribe to this channel for more coding and programming videos. Okay guys, thanks for watching.